In this class, now I am going to explain you how to evaluate integral is given in any one of these forms. Observe all these forms. See, in these three, here in the denominator cos x is there, here sin x is there, here combination of cos, sin and constant. Sometimes only combination of cos and sin they may give you. And observe all this. So here cos 2x is there, here cos x is given. Here sin 2x, here sin x. Here cos 2x, sin 2x. And also constant included. But when you go to this, in the denominator place, cos square x, sin square x is given. And when you go to the last one, observe all this and this one. In the numerator, this sin and cos functions are given. How to evaluate if the integral is given in this type of forms I explained you. Now let us discuss one by one. See, if the integral is given in any one of these three forms, observe all these three. In the numerator place only one is given. In the denominator places either cos function or sin function or combination of sin and cos function is given. So in these three forms, the substitution is tan x by 2 is equal to t. This is the substitution. And do the derivative on both sides with respect to x. So as you know, derivative of tan x by 2 is secant square x by 2. This is not x. Follow the chain rule. You get 1 by 2, which is equal to dt by dx. Now make dx as subject so that you get 2 dt by secant square x by 2. As you know, this secant square x by 2 can be written as 1 plus tan square x by 2 is equal to 2 dt by 1 plus, as we have taken tan x by 2 as t. Write the t value here, then it will become 2 dt by 1 plus t square. While doing the application, in the place of dx, what you people will take? 2 dt by 1 plus t square. How this dx equal to 2 dt by 1 plus t square? I hope you have got it. I took tan x by 2 equal to t. Then I did derivative on both sides. So I made dx as subject. I got dx equal to 2 dt by 1 plus t square. And in the place of cos x, I am going to write as 1 minus tan square x by 2 by 1 plus tan square x by 2, because here I am using submultiples formula. Okay, so cos x can be written as 1 minus tan square x by 2 by 1 plus tan square x by 2, so which is equal to 1 minus t square by 1 plus t square. In the place of sin x, what can you write? 2 tan x by 2 by 1 plus tan square x by 2. So which is equal to 2t by 1 plus t square. Okay students, I hope you have understood. We learned this formula in the trigonometry. Submultiples of trigonometric ratios. We studied as cos x equal to 1 minus tan square x by 2 by 1 plus tan square x by 2. But in this problem, we are taking tan x by 2 as t. So hence it will become 1 minus t square by 1 plus t square. What about sin x? 2 tan x by 2 by 1 plus tan square x by 2. In the place of tan x, write there t. 2t by 1 plus t square. Okay, to evaluate integral in any one of these three forms, in the place of dx, what you would have to take? 2 dt by 1 plus t square. In the place of cos x, 1 minus t square by 1 plus t square. In the place of sin x, 2t by 1 plus t square. Then go for simplification. I explain you one or two problems based on this. See, suppose integral is given in this form, like integral of dx by 3 plus 2 cos x. What did I say? In the place of dx, you would have to write 2 dt by 1 plus t square by 3 plus 2 into, in the place of cos x, 1 minus t square by 1 plus t square. Now go for simplification. Write these two outside. So 2 dt by 1 plus t square whole by, so 3 plus 3t square 2 minus 2t square whole by 1 plus t square. 1 plus t square, 1 plus t square cancel. Now write the 2 outside. dt by, simplify this, 3 plus 2, 5. 5 can be written as root 5 whole square, and here 3t square minus 2t square, t square. Now apply the standard integral formula. So whenever the integral is given in this formula, in this form, as you know, standard result is 1 by a tan inverse of x by a. Use that formula. In the place of a, root 5 is there. 1 by a tan inverse of x by a, x value t, a value root 5 plus c. What is t? In this, tan x by 2. At the end of the solution, in the place of t, write tan x by 2, so that it will become 2 by root 5 tan inverse of tan x by 2 by root 5 plus c. This is your required result. Okay, students? Right. See, suppose if the integral is given in this form, how do you evaluate? dx by 3 cos x plus 4 sin x plus 6. How do you do? Integral of dx by 3 cos x plus 4 sin x plus 6. In the place of dx, what you would have to write? 2 dt by 1 plus t square whole by 3 into, in the place of cos x, 1 minus t square by 1 plus t square plus 4 into sin x, which can be written as 2t by 1 plus t square plus 6. Now simplify this. So on simplifying this, you get 2 dt by 1 plus t square whole by, so here it is 3 minus 3t square plus 8t plus c. Take LCM here. 1 is there. So 6 plus 6t square whole by 1 plus t square. Now both of them cancel. Write these two outside. Integral of dt by, so here 6t square minus 3t square, 3t square, and this is 8t plus 6 plus 3, 9. Okay, here what I am doing, in the place of dx I wrote 2 dt by 1 plus t square. In the place of cos x and sin x, 1 minus t square by 1 plus t square and 2t by 1 plus t square. Now go for simplification. You have got a quadratic expression in the denominator. Now in the next step, what I have to do to evaluate this integral? So this denominator is looking like a quadratic expression. Now express this as, okay, completing square method. So you have to transform this one into x square plus a square, or a square plus x square, or x square minus a square. We have learned some methods. So transform this one into either in this form or in this form or in this form, any one of these three forms. See, now I am transforming this one into that previous three forms. Observe me. 3t square plus 8t plus 9. Now take 3 as common. So here t square plus, see, 2 into t into 4 by 3. Can I write? Yes. Here plus 3. So if you want again multiply these three terms with 3, again you will get this back step. See, 3 t square plus 2 into t into 4 by 3 plus 4 by 3 square whole square addition minus 4 by 3 whole square subtraction. In the next step I am going to write this one as t plus 4 by 3 whole square, add this one. So 9 3 is 27. 27 minus 16, which becomes 27 minus 16 students, which becomes 11. So 11 by see, 4 square 16, 3 square 9, 9 3 is 27. 27 minus 16, 11. So 11 by 9 you will get here. Okay, this you can write as root 11 by 3 whole square. Now go back and in the denominator place write this value and integrate it. So in the previous one there was 2 is there, write the 2 outside, and in the denominator what you have to write, this one you have to copy. 3 into t plus 4 by 3 whole square plus root 11 by 3 whole square. Okay, integrate it. 2 by 3, which looks like x square plus a square. Apply that standard result formula. 1 by a value root 11 by 3 tan inverse of x by a. So in the place of x, t plus 4 by 3 is there, by root 11 by 3 plus c. 3 cancel. Now 2 by root 11 tan inverse of, take cross multiplication and write in the place of t as tan x by 2 plus 4 by root 11 plus c. Like this you have to evaluate that given integral. But sometimes in the place of sin x and cos x they will give you sin 2x cos 2x. Like here 1 by a plus b sin 2x and 1 by a plus b cos 2x, or combination of sin 2x cos 2x are given. In such case the substitution is tan x equal to t. What is the substitution here? Tan x equal to t. In the previous ones tan x by 2 equal to t na, here tan x equal to t. Okay, now do the derivative on both sides with respect to x. Tan x derivative secant square x, which is equal to dt by dx. Now make dx as subject, you get dt by secant square x. Dx equal to dt by secant square x can be written as 1 plus tan square x, which is equal to dt by 1 plus t square. Okay students, what UPP have to write in the place of dx? dt by 1 plus t square. How that dx equal to dt by 1 plus t square? I gave you the reason. And also in the place of sin 2x, what you are going to write? You know, sin 2x in terms of tan. 2 tan x by 1 plus tan square x, which is equal to 2t by 1 plus t square. And in the place of cos 2x, 1 minus tan square x by 1 plus tan square x, which is equal to 1 minus t square by 1 plus t square. Okay, to evaluate this type of integrals, you would have to write dx equal to dt by 1 plus t square and sin 2x value 2t by 1 plus t square. Cos 2x 1 minus t square by 1 plus t square. At the end of the solution, write tan x as t. After simplification, at the end, you will get answer in terms of t. So, you have to replace that t by tan x at the end of the solution. Remember that. Now, let us see one or two examples. See, integral of 1 by 4 sin square x plus 9 cos square x. Tell me students, how do you evaluate? I gave you the concept for sin 2x cos 2x, but here sin square x cos square x's are given. Whenever the sin square x cos square x's are given, you have to replace cos square x by 1 plus cos 2x by 2 and sin square x as 1 minus cos 2x by 2. So you learned this formula in the multiples of trigonometric ratios. So replace these two by cos 2x and 1 plus cos 2x by 2 and 1 minus cos 2x by 2. So here dx by 4 1 minus cos 2x by 2 plus 9 into 1 plus cos 2x by 2. Okay. Right. Now in the next step 2 will go into the numerator. Write that to outside. dt by 4 minus 4 cos 2x plus 9 cos 2x. Okay. 2 into dt by 9 plus 4 13. 9 minus 4 5. Okay. Right. Hereafter, in the place of dx, sorry here, dx only, not dt, dx only. Okay, the next step we write in terms of t. So what you have to write? Dx equal to dt by 1 plus t square, not to 2 dt. So here whenever cos 2x and sin 2x are given, in such case you have to replace dx by dt by 1 plus t square, not to 2 dt by 1 plus t square. In the previous ones, whenever the sin x and cos x are given, in such case dx equal to 2 dt by 1 plus t square you got. But in this case, dt by 1 plus t square. Why? I gave you the reason. Isn't it, students? Right. Now, 13 plus 5. In the place of cos 2x, what you have to write? 1 minus t square by 1 plus t square. Okay? Right, simplify that. See, 2 into dt by, so 13 plus 13t square, 5 minus 5t square, whole by, in the numerator 1 plus t square is there, here also 1 plus t square, both of them cancelled. 2 dt by 13 plus 5, 18. So 13 minus 5, 8t square. Now take 2 common, cancel with this, so that you will get dt by, what do you get, students? 9 plus 4t square. 9 plus 4t square. Take 4 outside. So you will get 1 by 4 integral of So 3 by 2 whole square t square dt. You know, it is looking like standard result na 1 by a value 3 by 2 tan inverse of x by a, t by 3 by 2 plus c. Now how much is this? 1 by 6 tan inverse of 2t by 3 plus c. 1 by 6 tan inverse of 2 into t. So here t value is tan x, not tan x by 2. Tan x plus c. This is your required result for the given integral. Okay, students? Right. Now let us learn integral if it is given in this form. Right. See this integral of 2 cos x plus 3 sin x by 4 cos x plus 5 sin x. So observe the previous models and this one. In previous all those cases that sin and cos functions were given in the denominator places, but here that sin and cos functions are given in the numerator as well as denominator. Sometimes they may give you integral in this form also. 1 by 1 plus tan x dx or 1 by 1 or like this a plus b cot x dx, where a and b are any real numbers. In these cases you have to express this tan and cot in terms of sin coses, you know, sin by cos, and simplify. So if you simplify, so it will become, right, tan x as sin x by cos x, and simplify. You get cos x by cos x plus sin x dx. Then follow this method. Here also cot can be written as cos by sin. So you will get sin x by a sin x plus b cos x. Again came to in this form, and follow this procedure. Okay. See, in this type of applications, you have to write the numerator is equal to a into denominator plus b into d by dx of denominator. Okay, students, what you have to write in the place of numerator? A into denominator plus b into d by dx of denominator. Okay. Sometimes here constant will be given to you. In such case, you have to write plus c. Sometimes what do they give you? Here constant will be given, like p here q. In such case, you have to take extra plus c. But here in this problem, not required. Okay, students, right? See here 2 cos x plus 3 sin x, which is equal to a into denominator 4 cos x plus 5 sin x plus b into d by dx of denominator. Derivative of cos x minus sin x, minus 4 sin x plus derivative of sin x cos x, 5 cos x. Okay, students, now compare cos coefficients on both sides. Here it is 2, here it is 4a and plus 5b. You got one equation in terms of a and b. Compare sin coefficients on both sides. 3 is equal to here 5a minus 4b. Now solve both of them. On solving these two, you get a and b. So here, okay, I am solving both of them. This one I would like to multiply with 4, 8, 16a, 20b. This one I would like to multiply with 5, 15, 25a, 20b. Both of them cancelled, and here it is 23. So here it is 41a. Now your a will be 23 by 41. Okay students, write this A value either here or here so that you will get B. I am writing in the second one. 3 is equal to 5 with A. So I think 115. 523 is a 115 by 41 minus 4B. Now make 4B as subject. So transfer this one to the right side. 115 by 41 minus 3 by 1. Simplify that. What do you get? 4B, which is equal to 115 minus 125. Isn't it students? 3 1 is 3, 3 123 by 41. So what is the difference of these two? 4B, which is equal to minus 8 na? Minus 8 by 41. 4 1s are 4 2s are. Your B value will be minus 2 by 41. Okay? And go back in the place of A. Write this 23 by 41 and in the place of B minus 2 by 41 and integrate it. So here A value. This is equal to A value. How much have we got? I think 23. 23 by 41 of 4 cos x plus 5 sin x by denominator. Just in the place of numerator we are writing this. So both should be divided with the denominator. So here 4 cos x plus 5 sin x dx plus b value minus 2 by 41 of minus 4 sin x plus 5 cos x whole by 4 cos x plus 5 sin x dx. Now both of them cancelled. What is left? 23 by 41 integral of 1 dx is equal to x. So the derivative of denominator is given in the numerator. See, cos x derivative minus sin x cos x. Hence the derivative of denominator is available in the numerator. Hence whose integral will be minus 2 by 41 log mod 4 cos x plus 5 sin x plus c. So this is your required result for the given integral. Okay students, I hope you have understood this class. Thank you one and all.